In this video, we'll look at creating variables and performing some calculations on them. In order to store a value in a Matlab session or in a program, a variable is used. The easiest way to create a variable is using an assignment statement. The format is variable name equals expression or a value. Here, we have created a variable named a and we have assigned the value 2 to a. The variable is always on the left, followed by an assignment operator, followed by a value or an expression which gives the value. So something like this is wrong. Here, the value of the expression, that is 18 minus 4, which is 14, is stored in the variable b. Note that the spaces in the expressions do not affect the result but just make it easier to read. So sine 3 times followed by a space 5 gives the same value as sine of 3 times 5. Matlab uses a default variable ans, short for answer, if an expression is typed at the prompt and is not assigned a variable. So Matlab here assigns the value of 7 plus 3, which is 10, to the variable ans. A shortcut for retyping commands is the up arrow, which will go back to the previously typed commands. This is useful if you have typed in a long command wrong and you can just go back and correct it. Here I have missed a parenthesis. So now I just use the up arrow, go back, and close the parenthesis. To change a variable, another assignment statement can be used that assigns the value of a different expression to it. Consider the following sequence of statements. Here I've assigned the value of 3 to the variable I. And here I've changed the value of I to the value of expression 4 plus 2, which is 6. So now our variable I stores the value 6. In this statement, I am assigning the value of I plus 1, which is 7, again to the same variable I. So now the variable I stores the value 7. At this point, if we find I plus 3, it will be 10. Let's check that out. Note that typing just the name of a variable will display its value. If you want to suppress the output that you see on the screen, you end the statements with a semicolon. For example, now that we know how to create the variables, let's spend some time on the rules that we must follow while naming the variables. Variable names are a subset of the identifier names. Examples for other identifier names are file names, function names, etc., which we'll talk about in the subsequent sections. A variable name must begin with an alphabet. After that, the name can contain letters, digits, and underscore character, but cannot have a space. As you can see, a_1 is a valid variable name, whereas a space 1 just spits out an error. And so does the name 1a. There is a limit to the length of the name. The built-in function nameLengthMax tells you how many characters this is. Let's find that out. So apparently it is 63, and it would be work to think of a variable name longer than that. Matlab is also case sensitive. So we see that small a is not exactly same as capital A. We cannot use reserved words for variable names. ssc_reserved gives the list of reserved names in Matlab. The names of built-in functions also cannot be used for variable names. For example, let's see what happens when we actually do that. Here I'm assigning the value of 7 to a variable whose name is sine. Now, if I want to evaluate what is the sine of an angle, let's say sine of 3, I do not get what I want. Now let's look at some commands relating to variables. The command who shows variables that have been defined in the current session. The command whose shows variables that have been defined in the current session with more information. I get the size, the space it's occupying, and also what is called the class of the variable. The command clear clears out all the variables so they no longer exist. And now if I type who, I get nothing, which just shows that I have no variables. The command clear variable name clears out a particular variable. Let's create some variables. Let's say a is 5, b is 2 times a, so b is 10, and let's see if they're actually in our workspace. Well, so we have the variables a and b in our workspace. Now let's go ahead and clear the variable a by doing this. So the variable a has been removed and we're just left with b. Note that the variable b still stores the value 10 even though I cleared a. Expressions can be created using values, variables that have already been created, operators, built-in functions, and parentheses. Let's look at some examples, even though I'm sure you've seen them before. Two times sine 1.4. 2 plus 4 by 2 gives us 4. Note the precedence given to the operators here. Division is given the first preference and then comes addition, and hence we get 4 but not 6. 2 power 3, which is 8. If you have really long expressions, you can continue them on to the next line by typing 3 periods, also known as ellipses. For example, here, I jumped onto the next line by typing 3 periods and finishing the statement. You can also specify the format of the output by using the command format. The default in Matlab is to display up to 4 decimal places. Let's try out other format options that are available in Matlab. Now I've set the format to long, and Matlab shows me the values of a, and Matlab shows me the values up to 16 decimal places. The format short e displays the values in the scientific notation, and the format rat displays the values in the rational format. The command format can also be used to control the spacing between the Matlab command and the result. Let's try out format compact. As you can see, the space between the command and the output has been reduced. We can go back to the previous setting by typing in format loose. There are 3 kinds of numbers used in Matlab: integers, real numbers, and complex numbers. Integers are entered without a decimal point. If you enter a number with a decimal point, it is stored as a real number. The real numbers are stored as 2 basic types, single or double. The name double stands for double precision and it stores larger numbers than single, but really you don't have to worry about that just yet. Let's check how Matlab stores a. So Matlab stored a, which we typed in as 10.0 as a double, which is a real number. Now let's quickly look into how complex numbers are represented in Matlab. Complex numbers in Matlab are represented in rectangular form. The imaginary unit square root of -1 is denoted either by I or j. So if I wanted to create the complex number 2 plus 3i, I would just type in c equals 2 plus 3i. Of course, if I assigned I to be 1 and then type I, it isn't going to be the imaginary number anymore. I will have to reassign it. Now, coming to the basic computations, you name a mathematical operation and you can do it in Matlab. Help L1 gives you the list of elementary math functions. It lists the trigonometric, exponential, complex functions, and rounding operations. For example, ABS is the function which gives the absolute value of a number. So absolute value of -4 is 4. Sine is the function which gives the sign of a number. So it's -1. Round 3.14 rounds 3.14, which is 3. Ceil 3.6 gives the ceiling of 3.6, which is 4. SQRT gives the square root of a number. So square root of 2 is given in the rational format, if we remember right. So let's change the format back to short. And type in square root of 2 again. There you go, it's 1.414. E power 2 is given by the function exp of 2. Most languages have the capacity to store constants, values that are known ahead of time. In Matlab, we have pi, which is 3.14, I, which is the imaginary number, j, which is also the imaginary number, INF to denote infinity, and NaN denotes not a number, which is usually the result of invalid operations. For example, 0 by 0 or infinity by infinity. A common mistake is to assume that E is also defined. It is not. So if you want to use E, you would want to type in exp of 1. We finish up with the other basic type of value a variable can take, which is a character. A character in Matlab is represented using single quotes. For example, here I've assigned the character A to the variable mychar. A string is a vector of characters, and you can assign a string to a variable like this. Here I've assigned the string Melinda to the variable my name. With this, we end the introduction to variables and basic computations. Matlab is an array-based language, and the power of Matlab lies in its ability to manipulate vectors and matrices. Next, we'll look at how to create them and play with them in Matlab.